you all know that in the last class we were discussing the chapter motion, and we got some of the basic information related to this chapter. Just we shall go for recalling these important points. We know that when you go for taking any matter or any object, in physics we consider that as a body. Every body has two states. What are those? Yes, one is state of rest and second one is state of motion. Then what do you say about the state of a body if a body does not change its position with respect to its surroundings? It is state of rest. When a body changes its position continuously, see that I'm not at all standing at one side, just I'm been moving continuously, I'm changing my position continuously, then you can say that I am in motion. When a body changes its position continuously with respect to its surroundings, then it is said to be in motion. Then after that, we come across the different types of motion, maybe the circular motion, linear motion, rotatory motion, then oscillatory motion or periodic motion, vibratory motion, is it not? Now let me go for showing you some pictures and you should answer, identify these pictures and tell the type of motion related to this particular picture. Okay, Renuka will always be ready. Very good girl. Yes, observe this picture. First one, Prashant sir.
Yes, sir. Yes, sir.
Unmute everybody.
Okay.
Go for responding.
Okay, sir. Okay.
I'll ask question to particular student. Only they should respond. Ritika, first chance is for you. Here, observe this first picture. In this, a man is exerting the force on a box and the box is moving in a straight line. Then could you tell the type of motion experienced by this object, that is the box?
Linear motion.
Yes, it is linear motion. I have given chance to Ritika. Next, Manya A. Yes.
Yes,
You just come across this. Here we have a pendulum and you just take the bob to some distance and you leave that. You start moving like this. Could you tell?
Oscillatory
what?
or periodic motion.
Very good. Oscillatory motion or periodic motion. Generally, we say that it is oscillatory motion. Now, Dheeraj SK, observe this picture. Here we have the earth. And around that earth, you can see a path on which moon is moving, right? Could you tell what type of motion experienced by this moon?
Circular.
It is circular motion.
Yes, sir.
A chance is given to Ananya Tikar. This is here. Observe the fan. Observe this. Ananya. Here we have the fan. Leaves of fan are there. They start running. Could you tell what type of motion experienced by these leaves of the fan?
Motion.
It is rotatory motion, is it not? When you observe the tip of the leaves, then you can come to know that it is circular motion. Followed? Okay. And one more. Precious. This is for you. Observe this. We have taken a thread and it is tied from one end to another end. Then just you go for pulling it for some distance and leave that. Then could you tell what type of motion is experienced by this thread? Or else you may take, in place of that thread, you may take even rubber band as well.
Vibratory motion.
Very good. Huh? Vibratory. Yes.
Vibratory.
Vibratory motion. It is vibratory. Got it? So these are the different types of motion. Then after that, we come across the measurable quantities. Amulya CK, what do you call the measurable quantities? What do you call the quantity which can be measured? You know that length can be measured, breadth can be measured, area can be measured, your weight can be checked, time can be measured.
Physical quantity.
Very good. It is a physical quantity. And all the physical quantities are divided into two types. One is scalar, second one is
Scalar and vector.
Vector quantity.
I'll give chance. Tejasvi CP. What do you call the physical quantity having that has only magnitude, no direction at all?
Scalar quantity.
This is a scalar quantity. The physical quantity that has magnitude only is scalar. Example for that is mass, time. If you go for taking time as a scalar quantity, you can tell that how much it is, but you cannot show the direction. Therefore, time is a scalar quantity. And another one is vector quantity, a quantity that has both magnitude and direction. It is called vector quantity. Example, force. Weight is there. So force is a vector quantity because it has the magnitude, it has some value. And whenever you apply the force on a body, you can show the direction as well, whether it is moving away from you or towards you. That direction can be mentioned. So therefore, it is a vector quantity. Then, dear students, you all know that in this chapter, we are focusing on some important physical quantities. Among these, two were discussed. One is distance and second one is displacement. What do you call the shortest distance between initial position and final position of a body?
Displacement.
Displacement. Displacement.
Yes, sir. Shreya, could you tell one similarity between distance and displacement?
Their SI unit are same, sir.
Very good, very good. SI unit of distance and displacement, both same. SI unit of distance is meter and displacement is also meter. And we have other differences. Which of these two physical quantities will always be positive or zero?
Distance.
Distance. And another one.
Distance.
This displacement may be zero, positive or negative.
Displacement.
Renuka MY.
Yes,
Could you tell under what condition distance and displacement are equal in magnitude? In what situation you can say that the displacement is equal to distance? Yes, Mohita. Could you tell? Mohita VG? Okay.
If the body
if your body
moves in a
moves in-
straight line.
If the body is in a straight line.
Enough. When a body moves along a straight line, then you can say that it's distance and displacement. We say, dear students, again I'm going to show you another picture. Arshi, observe. I'm going to show you another picture. Observe. Here we have two positions of a body. One is A and another one is B. Observe this part, blue colored part, and even we have shown that with a dotted line in red color. It is ACDB. Does it represent distance or displacement?
Distance.
Distance. Distance.
Because this is the length of actual path which body has traveled. Next, what do you say from A to B?
Displacement.
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 Displacement. Will it not be distance?
Displacement.
It may be
It will
distance.
be
Sir.
distance
Yeah,
or
very
Can
good.
be even distance also, sir.
Very good. Even it may be distance also. See that? A to B. Either you may take this as either distance or displacement. Both will come. Okay.
Sir, is pressure scalar or vector quantity, sir?
It is a scalar.
Why? Sir?
The reason is it has you can mention only magnitude. You cannot mention the particular direction. Let me give you one example. See that suppose you go for taking a balloon, you'll go for blowing the air into it. Then the size of the balloon increases. Could you tell in which direction pressure is there? Can you show the particular direction?
No, sir.
Pressure is there here or
No,
here?
sir.
Here it is all around inside the balloon. Is it not? You cannot mention the particular direction. Followed? So that's why it is to be considered as a scalar quantity.
Sir, you have shown the figures. No, sir.
Huh.
Please explain the third one, sir.
Types of
That's-
motion, huh?
Yes, sir.
Which is
The third one, sir.
third one.
Circular motion.
Yes, sir. Please
Curve
explain.
motion.
Curve motion.
It is
Curve
curve.
motion.
Look here. Not linear. Here, the ball is changing. Ball is kicked by a ball, and the ball is moving not in one particular direction. Every time it is changing. If it moves around one fixed point, then you can say that it is circular. Followed?
Yes, sir. Sir, a ball is rolling from this slide. Is there which motion, sir?
If the ball moves on the slide, it will be
Yes,
a straight, linear.
Yes,
And
sir.
at the same time, it will be rotating as well. Therefore, it belongs to a complex motion. Got it?
Okay, sir. Okay, sir.
Dear students, this much was discussed in the last class. Now we are moving to take some numerical problems on distance as well as displacement. I'll go for taking very simple one. Listen to me carefully. Listen to me. Here, this is a straight line, a straight path. And this is the initial position of a body or initial position of an object. Don't go for writing anything. And these are the different positions of this body. I call it as B, C, this as D, and this is E. It has started moving from here. Then it moves up to the point D. It takes the position D. From A to B, B to C, C to D, D to E. It is same distance. I take this as 10 meters. I've given you the initial position of a body or a person. It is a final position is D. This is final position. My question is, what is the distance traveled by the body?
30 meters.
30 meters.
30 meters.
30
30
meters.
meters.
Okay. Prajwal Esther, what about displacement?
30 meters.
That is also 30 meters. Could you give the reason why distance and displacement both are equal in this case?
Sir, because the body moves in straight line or linear.
Very good. Very good. A body has moved in a straight line in the same direction. Therefore, distance and displacement both are same. Next, one more. This is the ground. You have taken a ball and you throw it vertically upward. It reaches some height. I take this height as total h meter. Will it come back?
Yes, sir.
once
Sir.
the ball is
Yes, sir.
Yes.
Yes. Shubhanil P. Nalpate. Why it comes back? Why the ball falls back to the ground?
Gravitation.
Sir, because of gravity.
Gravity.
Gravity, nothing but gravitational force of the earth. Okay. Assume that the ball has fallen to the ground in the same path. My question is, what is the distance traveled by the ball?
2h.
Distance traveled by the ball.
2h.
2h.
2x.
2h.
2h.
And
2h.
moves from ground to this height. Next, from this point to the ground. Total 2 times h. Therefore, distance is h plus h is nothing but 2h. Then, Yatin.
Yes, sir.
Yes. What do you say about the displacement of the ball?
0.
It is
0.
Are you sure?
Yes, sir.
Wait.
Yes,
Yatin.
sir.
Could you tell why the displacement is 0?
Initial and final position
Sir,
are
because
same.
Very good. Very good. Because the initial position and final position of the ball is same. The shortest distance will be 0. Hence, the displacement will also be 0. Clear up? Yes. Now, we should move on to numerical problem. Right. Quite quick as possible. Numerical problems. Numerical problem. First one. Right, as given in the reference book. Right. A man walks 6 meters towards east. A man walks 6 meters towards east. Then 8 meters towards north. Towards north. Right. Fine. First, the total distance covered by him. The total distance covered. And second one is displacement. Displacement from initial position. Initial position. Have you copied? Sanjana G, have you copied?
Yes, sir.
Okay. Have you understood the statement?
Yes, sir.
You can answer first one directly.
Yes, sir. Yes, sir.
How much?
Yeah, also given in
Wait.
sir, 14 meters, sir.
Very good, very good. It is the distance traveled by the man. First, that man covers 6 meters. Next, it covers 8 meters. 6 plus 8, 14 meters.
14 meters.
Sir, displacement 10.
Let me tell you.
Displacement 10.
10, sir.
10, sir, displacement.
Just look at the word. It is a direction related problem. Sarthak Hardy, you may stop writing. Larissa.
Excuse me, sir.
Go through the
Excuse me, sir.
Yes,
Excuse me, sir.
Yes, sir.
Excuse me, sir. Sorry for the disturbance. Dear children, here I am going to give you some instructions. Everybody must follow. Okay. If it happens next, so I am not a responsible person. Keep this in your mind. First thing, so don't turn off your video. The second point is, once you enter the class, complete 1.5 hours, you have to concentrate on class. Okay. So suddenly you are left from the meeting and again you are going to join. So it is not allowed from today onwards. And the important point is, so what are the instructions sir has been giving you? Please follow. Please follow. It should not be continue again and again. So everybody must turn on your video when you enter the classroom. Okay, and within 7:40, within 7:40, you have to join the class. After 7:40, so we are not going to admit. Thank you, sir. You may continue, sir.
Okay, okay, thank you very much. Dear students, once you go to the state, a man walks 6 meters towards east and then 8 meters towards north. So just by going through first sentence only, you can come to know that it is direction related problem. Here, I am going to mention the direction. Observe. This is north. This is south. What about this?
East.
East.
And
West.
West.
let us take the initial position of a man as this point. I call it as A. Observe this one. Go through first sentence. A man walks 6 meters towards east side. He covers a distance of 6 meters and takes a position. I call this as point B. Let's look at. Then immediately he starts moving towards north and covers a distance of 8 meters. That means whether he takes left turn or right turn to move towards
Straight,
north.
sir. Straight.
Yeah,
Straight, sir.
left, left, left,
Left.
Enough. He is moving towards north, then he takes left turn. After taking left turn, he covers a distance of 8 meters. And this is his final position. I mentioned it as C. The question is, what is the total distance covered by him? Look at total distance. He has started from the point A, comes to B, then he goes to C.
Sir, we should find out the side by Pythagoras
AB
theorem.
distance plus BC distance. That is 6 plus 8. It is 14 meters. Followed? This is the total distance. Next, total distance. Then is displacement. Displacement. It is the shortest distance between initial and final position of a person.
10 centimeters.
Wait. Initial position is A. Final position is C. The direct distance from A to C. Kusha, how do you go for finding the distance from A to C?
By
Pythagoras.
using Pythagoras
Wait.
theorem.
It is by using Pythagoras theorem or Pythagoras property. Okay. Because we got a right angle triangle and AC is the hypotenuse. To find out the hypotenuse, we have to use Pythagoras property. So let's go for that. Now please start writing with me.
Sir, we should take the diagram.
Huh? Yes,
Sir, we
you must. You must.
okay.
It will be easy for understanding. Directly I'll move on to calculation. Please write with me. First, let us find out the distance. Distance is, it is AB plus BC, right? AB plus BC, where AB is 6 meters and BC is 8 meters, which is equal to 14 meters. 14 meters. Over. So this is the distance covered. Here only you can write the conclusion. Therefore, the distance covered is 14 meter. Now let's want to find out the displacement. To find out the displacement, we will go for using the triangle ABC, right? In triangle ABC, you know that angle B is 90 degree, right? Angle ABC, it is equal to 90 degree. By Pythagoras theorem, please go on writing with me. It is AC square is equal to AB square plus BC square. AB square plus BC square. Substitute. AB is 6 meter, right, whole square. BC is 8 meter, as it is square, right, whole square. Amok, sit properly. Amok. Fahim. What is 6 square?
36.
36.
8 square?
64, sir.
64.
Fahim is telling. Fahim, what is the sum? It will be 100. 36 plus 64. It is 100. AC square equal to 100. We want only AC. So AC is equal to, here square is there. Apply root to the right hand side. Square root of 100.
10.
Then Virupakshi,
10.
what is square root of 100?
10.
It is 10.
10.
AC is 10 meters. Right. So the shortest distance from initial position to the final position of a man is, it is 10 meters. Right. Therefore, the displacement of a man, or just you may write, displacement is 10 meters. Displacement is 10 meters. Ora,
Sir, can displacement be greater than distance?
it's not possible. Either it may be equal or it may be less than that. Displacement may be equal to the distance or it will be less than the distance. Never be more than the distance. Okay, just only for discussion. Look at here again. I mentioned the direction. You should not go for copying. Just you have to observe them. This is north, this is south, this is east, this is west. And assume that this is initial position of a man. You start moving from here. You start moving towards north and covers a distance of around 12 meters. 12 meters. Then it takes left turn. Then it starts moving towards west and covers a distance of 5 meters. Now you tell that what is the total distance covered by him?
17
17
meter.
meter.
17, sir.
17 meter.
17 meter.
17 meter.
Correct. Akshay, could you tell what is this displacement?
30.
Displacement of a man. Just mind calculation is enough. If
13,
anybody knows, you can.
13 meters.
Very good. Very good.
13 meter.
13 meters. See that? This displacement. Here 5 square plus 12 square. 5 square is 25, 12 square is 144. This will be 169. Square root of 169 is 13.
15 meters.
Hence, the distance will be 30 meters. Got it? Next, I'll take one more. Just observe. A man he has started moving from his initial position towards the south and covers a distance of 10 meters. Then he takes left turn. If he takes left turn, whether he moves towards west or east,
West.
East.
West.
East. East.
West. West.
east, west,
West.
south, you tell all the directions. I'll choose.
West,
East,
sir.
sir.
East,
West,
sir.
sir.
East, sir. East,
East.
sir.
East.
East, sir.
East.
He has started moving from his initial position. Then he comes to this position. He takes left.
East. East.
When he
West.
takes left turn, see that he is moving. Then it starts moving towards east.
East.
Got it? Observe the direction. Then again it takes left turn. First he covers 10 meters, then he covers around 8 meters. Afterwards, again it takes a left turn. If he takes left turn, whether he move towards north, east, west, south,
North. North, sir.
north,
North.
and covers the distance of 16 meters. Followed. Now my question is, what is the distance traveled by him?
34 meters.
34 meters.
Very good. Look here.
34 meter.
First he covers 10 meters, next 8 meters, next 16 meters. 10 plus 8 plus 16. 10 plus 8 is 18. 18 plus 16. It is 34. 34 meters is the total distance covered. Anybody who would like to tell the displacement?
10 meter.
104
meters.
10 meters, sir.
Very good. Who is telling?
Jakno.
Jakno. Very good. Very good. You are right. I'll explain that. This is his final position. To find out the distance from initial position to final position, you must know this distance as well as this. What about this?
8
The distance
meter.
from
8
here to
meter.
here, it is 8 meters.
8 meter.
The distance from here to here, see, total 16. In that, here is 10. This is 10, and because opposite sides, and this will be 6.
6
Altogether
meter.
it is 6 meters. See the 8 meter, 6 meter. Using Pythagoras property, it will be 10 meters. So in the examination, they may ask you the question like this also. Just don't stick on to only the one problem what I have done. Even they may give in this way as well. Next, I go for giving you the next problem. And before going to next problem, just one information. Let's go for recalling it. This information you have already learned in your previous class as well. Look here. There is a circular path. There is a circular path, and from one position, at one position, call it as A, you are there. And you start moving along this circular path. If you complete one round, could you tell what distance you have covered? If the radius of the circular path is R units.
2 pi r.
2 pi r.
See, radius is R unit. You are going to cover, you'll move one round around this circular path. You start from A, then you move like this along this path, then you finally come to the same position. The total distance covered by you is nothing but distance around the circle. Distance around the circle is also called circumference of the circle. What is circumference of the circle formula?
2 pi r.
2 pi r, sir.
2 pi r.
So the distance covered by you, it is 2 pi r. Could you tell what is your displacement?
0.
0.
It is 0.
Zero.
Very good.
Zero.
Because
Coming back
initial
same.
and final
Initial
position,
point.
both are same one. Now, my another question. You have started from A. Larissa. You have started from the position A. You start moving along the circular path and you cover halfway distance in the circular path. And you take the position here, I call it as B. My question is, what is the distance covered by you?
Pi r.
2 pi r.
Very good.
Pi r.
Who said?
Only pi r.
Pi r.
Pi r.
Pi r.
Only pi r.
Only pi r.
A to B, this distance is 2 pi r by 2. That is half of the circumference. Only pi r. Anybody want to tell the displacement? What is the
2r.
displacement?
2r.
Diameter.
2 r. 2 r.
Diameter.
Diameter
2r.
or 2r.
Diameter.
This is
Diameter
initial
or
and is final position. The direct distance from initial to final. This is R unit. This is also R unit. Both are radial. R plus R, 2R is nothing but diameter. So displacement is diameter or 2R. Clear? Do you have any doubt?
No, sir.
No doubt. Now I'm going to give you one problem regarding this. Right. And this was given in the examination as well. To start one. Second one. It is a cattle tied to an oil seed crusher. A cattle tied to an oil seed crusher. He is moving in a circular path. He is moving in a circular path. In a circular path of radius 7 centimeter. Have you written the same?
Yes, sir.
Okay. Can you tell, is there anything wrong? Huh? I want to test your some common knowledge.
Sir, diameter, sir, 7 meters.
Diameter is not given.
Shreya, just ask him to move away. Ask your brother to move away. He will always come and disturb you. Okay. Anybody?
Sir, diameter not given.
Not mention 7 meter diameter already.
Very simple.
7
Common thinking. Is it
Sir,
possible
how can it
to?
be cm, sir? How can it be 7 cm? How can it be only
That is what-
centimeters?
That is only I have been telling. See, is it possible to tie a cattle to an oil seed crusher with a distance of 7 centimeter?
No, sir.
Agata, illa. So it is meaningless agata. So that the right one is 7 meter. 7 meter distance, it can move around it. Yes, right. In a circular path of 7 meter. Find. First, the distance covered by it. The distance covered by it covered by it. If it completes 15 rounds. 15 rounds. Next. Find its displacement. Displacement. Come on. When it completes. When it completes. When it completes 3.5 rounds. Three and a half rounds. These are two different statement they have asked. Have you copied?
Yes, sir.
Okay. Look at it. Once you go through the statement, a cattle tied to an oil seed crusher is moving in a circular path of radius 7 meter. Larissa should look at the board. Here, I'm going to draw a circular path on which the cattle is moving. This is the fixed point. And it is, cattle is here, it is tied to an oil crusher. This is an oil crusher. The distance from oil crusher to the cattle is how much?
7 meter.
7 meter. It is 7 meter. From here, it starts moving. How many rounds it completes?
15 rounds.
15 rounds. Okay. 1 round, second, third, fourth, like this. Then how do you go for finding the total distance covered by the cattle?
By finding the circumference of
the distance covered by the cattle in 1 round. Okay.
Oh, yeah.
1 round. The distance covered by the cattle in 1 round is nothing but perimeter of the circle. 2 pi r. If it is 15 round, 15 into 2 pi r.
Yes, sir.
Did you understand?
Yes, sir.
Yes, sir.
Okay.
50.
First, let us go for answering this one. Write with me. Go on writing with me. Here, distance between cattle and oil seed crusher. I take this as radius. It is r. R equal to 7 meter. Directly we shall move on to calculation. First one. Distance covered in 15 rounds. Right. Distance covered in 15 rounds. That's equal to 50 into perimeter of the circle. Shall I write the formula of perimeter of the circle directly?
Yes, sir. Yes, sir.
15 into 2 pi r. This is equal. What is 15 2 sir?
30.
30.
30.
5. What is the value of pi?
22 by 7.
22 by 7.
22 by 7. And radius?
7.
Distance
7 meter.
7.
7 get cancelled.
7 and 7 get
660.
2002.
660.
660.
60 meter.
Into 15. Ah, sorry, sir.
Directly we have calculated. No need to go for multiplying 15 again.
Yes, sir.
So we have found out the distance covered by the cattle in 15 rounds. So 15 into 1 round. 15 into 2 pi r. On substitution with calculation we have got 660 meter. Write the conclusion. Therefore, the cattle covers a distance of 660 meter in 15 rounds. 660 meter in 15 rounds. Voila. Now
Displacement is
listen.
14 meters, sir.
Listen here. If it completes 15 rounds, then what will be the displacement?
0.
0.
It will be 0.
Zero.
Because initial and final
Yes, sir.
position will be same.
Same.
Observe second question. Or ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ನೋಡಿ.
3 by 2.
Wait.
Half
Yeah.
11.
If it completes 3.5 rounds complete ಮಾಡಿದ್ರೆ what will be the displacement, not distance.
11 meter.
Displacement.
1 by 2 meter.
14 meters.
Wait.
11 meter.
Look at the board. See, one round. This is second round. Completes third round. Next half round. When it comes to half round, it takes the position here.
Diagonal.
Displacement from here to here. How much it will be?
14 meters.
14 meter.
14 meter.
This is 7. This is 7. Total
14 meter.
14 meter. Clear up?
Yes, sir.
Yes, sir.
Displacement of the cattle, if it covers or if it completes 3.5 rounds, is nothing but diameter. Right on. I'll rub this. Right, second one. Second one. Displacement. If 3.5 rounds completed, or after covering 3.5 rounds completed, that is equal to diameter of the circle. Diameter. You all know that diameter is 2 times of radius. I can write 2r. And you also know the radius. What is the radius?
7 meter.
7 meter.
7 meter.
This is 14 meter. 14 meter. Right to conclusion. Therefore, the displacement of the cattle
Is 14 meter.
is 14 meter. 14 meter. It is after covering 3.5 rounds. Over. One simple, again, general sense question. If it completes 1.5 rounds, what is the displacement?
14 meter.
14 meter.
14 meter only. It doesn't change. If it completes 10.5 rounds,
14 meter.
40.
Meters.
again 14 meter. Got it?
Yes, sir.
Next, I'm taking the textbook problem. It is very important and it was also given in the examination.
Double star.
Third,
7.
third one, right. A farmer moves along the boundary of a square field. A farmer moves along the boundary of a square field. Along the boundary of square field. of side 10 meter of side 10 meter in 40 seconds. Full stop. What will be the magnitude of displacement? What will be the magnitude of displacement of the farmer? Displacement of the farmer. Displacement of the farmer at the end of 2 minutes 20 seconds. 2 minutes 20 seconds. Over.
Yes, sir.
Okay. This was given in the examination as well. You can put double star mark for this. Double star. Now, once you go through the step, go through this. A farmer moves along the boundary of a square field. So here they are given a field. What is the shape of that field?
Square.
It is the shape of square. You can go upwards, you can draw. Okay. It is a square field. I call it as ABCD. ABCD is a square field. A side 10 meter. We know that in a square, all sides will be equal. Then each side they have given, it is 10 meter. This is 10 meter, is 10 meter, this is 10 meter, even AD is also 10 meter. Next, a farmer moves along the boundary of a square feet upside 10 meter in 40 seconds. Could you tell what does 40 seconds indicate?
To complete one round.
Very good.
Completion of one round.
Very good, very good. Farmer will take 40 seconds to complete one round. That means if you take A is initial position, he starts moving along the boundary of this field. A to B, then B to C, C to D, D to A. So finally it comes to A. To cover one round
40 seconds.
along the boundary of the field, it takes 40
seconds.
Now, question is, what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds?
20 meter.
If you want to know that, you must know total how many rounds he has completed in 2 minutes 20 seconds. He has completed one round in 40 seconds. In 2 minutes 20 seconds. 2 minutes 20 seconds.
So 20.
On 40 seconds.
Wait. 2 minutes plus 20 seconds. 2 minutes is equal to how many seconds?
120 seconds.
120
seconds.
120 seconds.
120 seconds.
120.
120 seconds.
120.
140.
Isn't it? Farmer will move for a time of 140 seconds. It move for 140 seconds. In 140 seconds, how many rounds he completes?
3.5 rounds.
3.5 rounds.
For one round, wait. For one round, he has taken 40 seconds. Number of rounds completed in 40 seconds is 1. Number of rounds completed in 140 seconds. It is 140 by 40. 0, 0, then it is 7/2. This will be 3.5 is nothing but 3.5 rounds. He completes 3.5 rounds in 2 minutes 20 seconds. If his initial position is A, what will be his final position after completing 3.5 rounds?
Zero.
C.
Zero. C.
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 Look at the book.
Half of A is
One
C.
round. Wait. 1 round. 2 rounds completed. Then 3 rounds over. But here 3.5. Remaining half. So his final position will be
C.
C.
Five
Got it?
Yes, sir.
If so, what is his displacement? Which
20
means that
meter.
we are going to find out AC.
AC.
Can you tell directly what is AC?
200.
200.
Oh,
200.
20.
20 meters.
20.
it is 2 times
20.
20.
Sir, 20.
100.
Sir, 20.
20.
100.
20 meter.
it is
20 meter.
10 times root 2. Look at how simple it is. 10 square plus 10 square. 10 square plus 10 square. We want AC. AC square. It is 100 plus 100. 200. AC equal to 200. And 200 can be done as 100 into 2.
Two.
Square root of 100. 10 into
10. 2.
10 times root. Have you got it?
Yes, sir.
Now, let's go for writing steps. First, draw a square. Take scale and pencil quickly. Scale and pencil and draw a square. All sides should be same. This as A, B, C, D. This is A, is B, C, and this D. Ora. In data, start writing. Farmer moves along the boundary of a square field. Let A, B, C, D be a square field. Square field. They what they have given, each side of the square field is 10 meter. So you can mention that 10 meter. 10 meter. Right. It is AB is equal to BC is equal to CD equal to DA. All sides are equal. This is equal to 10 meter. You can call each side as small a equal to 10 meter. Next, then given 40 seconds. What does it represent? 40 seconds.
1 round.
1 round.
1 round.
Time
One
taken
round.
by the farmer to complete 1 round along the boundary of the its field.
Square field.
Right. Just below this only. Time taken to complete 1 round of the field. That is equal to 40 seconds. 40 seconds. Next, what does 2 minutes 20 seconds indicate?
140 seconds. Took
40 seconds.
It indicates total time for which a farmer has moved. Right. Total time for which farmer moved is equal to 2 minutes. 2 minutes 20 seconds. Write this as 2 minutes as 120 seconds and 20 seconds as it is. This is equal to 140 seconds. So this much has been given. Now let's go on to calculation. Right. Calculation. We are going to find out the displacement of the farmer at the end of 2 minutes 20 seconds. Let us assume his initial position as A. Write that. Let A be the initial position of farmer. Let A be the initial position of the farmer. Over on. Next. First, you have to find out the number of rounds he has completed in 140 seconds. Right. Number of rounds completed. Number of rounds completed in 140 seconds. Right with me? 140 divided by 40. That is total time taken by time taken to complete one round. It is 140 by 40. Then 0 and 0 get cancelled. It is 14 by 4. Nothing but 7 by 2. Directly I go for 90. It is 3.5. 3.5 rounds. Over up. 3.5 rounds. Next. As I said, if A is the initial position of the farmer and the position of the farmer after completing 3.5 rounds, where it is?
C.
Right. I'll rub this part.
Sir, how 3.5 came, sir?
In question.
Question. Hey, question they are not given. Observe. Here, 0, 0 get cancelled. 14 by 4. 2 2s are 4. 2 7s are 14. 7 by 2. Half of 7 is 3.5. Abhinandan, have you got?
Yes, sir.
Good boy. Now I'll rub this. Now, let us write the position of the farmer at the end of 2 minutes 20 seconds. Nothing but after covering 3.5 rounds. The position of the farmer at the end of 3.5 rounds. In bracket you may write 2 minutes 20 seconds. 2 minutes 20 seconds is, what is this position?
C.
It is C. Now, if you want to find out the displacement, that is AC, you must go for construction. That is, you have to join AC, right? There. Join AC. Join AC. Now, let's go for using the triangle. Right. In triangle ABC, angle B equal to 90 degrees. Because in a square, each angle is 90. Let's go using Pythagoras theorem. My Pythagoras theorem, you can write AC square equal to AB square plus BC square, where AB is 10 meter whole square, BC that is also 10 meter whole square. 10 square is 100, 10 square is 100, total 200. AC equal to square root of, you may write 200 or else 100 into 2, however you want. It is equal to square root of 100 into 2, where square root of 100 is 10 then root 2 as it is. Now we will write the conclusion. Therefore, the displacement of the farmer at the end of 2 minutes 20 seconds is 10 into root 2 meter. 10 into root 2 meter. Finished up? Finished?
sir.
Okay. Now I'll rub it. So all the types of numerical problems are over. Now we are moving to the next concept of this chapter. Listen, dear students, now I'm going to show you 3 pictures. Just observe and tell your general information. A particular science concept RET and Kera. Just general information. Everybody should look at them. Look at me. Just observe this picture. Now I'll ask Ranjan or Pisale. What do you observe in this picture, Ranjan?
Sir, a cheetah and a deer.
Cheetah and deer are there. Okay. Prashast, what do you say?
Mountains and trees.
It's unequal distance.
No. I'm not asking. Science concept just general information. This picture nodi takshane.
A cheetah is
What
running.
Cheetah is chasing the deer.
Very good.
The
Very
cheetah
good. Generally, cheetah is chasing the deer. So it is running behind that. Now, Dheeraj, will the cheetah catch the deer?
What, sir?
Yes, sir.
The cheetah
sir.
catch the
Yes,
deer.
sir.
Yes, sir.
Yes, sir.
sir.
Why it is so?
Sir,
Because it is hungry.
way
Cheetah is the
faster than a
fastest
deer.
runner.
Very good.
Than a deer.
Very good. Very good.
Cheetah is the
Because
fastest.
cheetah can move faster than
Deer.
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 Is it not? So that is why
sir.
it is possible to catch. Next, the student. Here I'm showing one more picture.
Rocket.
Here is one and
The
here is
rocket.
one. Wait. Just listen to me. Prashant, what do you say about this picture? This one.
A ball is thrown vertically.
Wait. An object has thrown vertically upward. Is it not?
Yes, sir.
Here, an object it is thrown vertically upward.
Sir, it is falling to earth. Sir, it is falling to earth.
Vinandan, you just listen properly. Here we have the rocket. When the rocket is launched, will it fall back?
No, sir.
No, sir.
Continuously.
Yes, sir.
Is it not? Whereas
No,
this, when the object is thrown vertically upward, like a ball, stone, then it will fall back. You know the reason for that.
Yes, sir.
Here, this object will fall back to the ground. It is due to gravitational force of the earth. Then when the rocket is launching, when the rocket is ascending, will there be gravitational force acting on it?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
If it is so, then it should fall back to. Why
Sir,
it-
it has-
There is pressure
Force
come back, sir.
Pressure is exerted a lot.
Yes,
Wait.
sir.
Sir,
Enough.
there is pressure come back, sir.
Here, whatever the initial speed will be given to the rocket is much. It moves with a greater speed. It moves very fast, such that because of this fastness or speed of the rocket, it will escape from the gravitational force of the earth. So that is why once it is ascending, it will not fall down. Whereas this ball, we have given very small amount of force to that. Is it not? That is, as a result of it, its speed will go on decreasing as it is ascending. When its speed reaches, when it reaches to the maximum height, it will be 0. Then it starts falling towards the ground. Understood?
Yes, sir.
Yes, sir.
You can
Yes,
come
sir.
to know from these two pictures, you can come to know that here cheetah can chase the deer. It is because it can move faster than the deer. And here,
Pressure is more.
in this figure, the rocket will not fall back once it ascends. The reason is it moves much faster, such that
Faster
it can
than the-
escape from the gravitational force of the earth. In whatever the word I am using, the fast, we have
Speed.
particular word in science. Very good. It is
Speed.
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 Yes, speed. Speed is another physical quantity. Then how do you come to know the speed? You will also observe many vehicles which are running, and when anybody moves faster, you will tell that that person is moving moving with a greater speed. Is it not? So speed is a common word that we use in our day-to-day life. Then what is the scientific definition for speed? Then how does it
The distance covered in the unit
calculated?
time.
Kilometer per hour.
I'll tell you that. I'll tell you that.
Distance covered by time taken.
This is the bar. Assume that a person is riding the bike, not bicycle. It is bike. And it is the initial position of the bike. And he is riding the bike and it covers a distance of around 60 kilometer. 60 kilometer and takes the position B. And to cover the distance of 60 kilometer, it takes 2 hours. 2 hours. Okay, the distance covered or the distance traveled by the bike is 60 meter and the total time taken is 2 hours. Could you tell in 1 hour how much distance it can cover?
30 kilometers.
30
kilometer.
kilometer.
If so, wait. Amulya speaking. Then how do we get that 30 kilometer?
Divided by 2.
Very good.
60 divided by 2.
To cover 60 kilometer, it has taken 2 hours. In 1 hour, you divide 60 by 2. This is equal to 30 by 1, where 30 indicates distance. 1 indicates
1 hour.
time. Distance is measured in kilometer, time is measured in hour. Got it? You can say that it is 30 kilometer per hour, which means that the bike is moving with a speed of 30 kilometer per hour.
Per hour.
Whatever the distance you may cover, whatever the time you may take to cover the distance, if it is calculated for 1 unit, you may calculate it for 1 second or 1 minute or 1 hour, 1 day, like this. That the distance covered by a body or the distance covered by a body, the unit time is nothing but speed.
Speed.
Understood?
Sir. Yes, sir.
Once I
Yes,
repeat,
sir.
the distance covered by a body in unit time is called speed. And for calculating speed, it doesn't mean that the body should always move in a straight line. Even it may move in different path, third line also. Okay. Assume that this is the initial position of an ant. Ant is taken and it starts moving from here and moves along this path, finally comes to the position B. When you find out the length of this actual path covered by an ant, it is around 10 meter. 10 meter. Got it? To cover 10 meter distance, to cover 10 meter distance, it has assumed that it has taken 120 seconds. That means 2 minutes. Could you tell what is the distance covered by the ant in 1 second? How do you go for calculating? This
10
is
by 120.
10 meter by
120.
It will be 0 and 0. It will be 1 by 2. It is 0 point some digits you will get.
Yes, sir.
Yes, sir.
Then 1 by 12 meters per second. This is its speed. Hello? Hello?
Unmuted,
Another
sir.
one. Another one. A boy is riding the bicycle on this path. Now he covers a distance. I take this distance as
10 kilometer.
100 meter. He has taken to cover a distance of 100 meter. He has taken 20 seconds. Then could you tell what is the speed with which he has moved?
15 meter per second.
50 meter per
50 meter per
Covered 100 meter in 20 seconds.
5 meter per second.
Very good. Then
5 meter
the
per
distance covered by
second.
him
Meter per
in 1 second can be calculated like this: 100 by 20.
20.
So 0, 0 get cancelled. It is 5 meter per second, which means that when he is riding the bicycle, he is moving with this speed, 5 meter per second.
Per second.
And another meaning is for every second, he is covering a distance of 5 meters. Got it?
Yes, sir.
Yes, sir.
Yes, sir.
Look here, look here. Now, if I go for taking the direct distance between initial position and final position of a body and the total time taken.
Bye, Emma.
Look here. It is a man is riding the bike on a straight path. He covers 60 kilometers in 2 hours. Then in 1 hour, how much distance he will cover?
30 meter. 30 kilometer.
30 by 2, it is
30 kilometer
30 kilometer per
per
hour.
hour.
If you go for calculating this speed, when a body moves along a straight line, then we call it as velocity. Got it?
Sir.
In case of velocity,
Yes, sir.
we consider displacement and time. In case of speed, we consider distance and time.
Sir, tell again.
One second.
Sir, explain once again.
I'm doing the same. Okay. This is initial position and is final position of this bike. And a man will ride the bike in a straight line. Could you tell what is the displacement of this bike?
30 kilometer per hour.
What is the displacement of the bike?
60 kilometers.
60 kilometers.
For this
60
displacement,
kilometers.
how much time has been taken?
2 hours. 2 hours.
2 hours. 60 by 2. It is
30 kilometers per hour.
Per hour.
the displacement of the bike in 1 hour. The displacement of the bike in 1 hour is 30 kilometers. And if the displacement is calculated in the unit time, then it is called velocity.
Yes.
Followed? The distance traveled by
Yes,
a
sir.
body in unit
Yes,
time
sir.
is speed. The displacement of a body in unit time is velocity. So now let us get more information about speed and velocity. Right. Right. Right side heading. Speed and velocity. And velocity. Speed and velocity. I'll take first about speed. Speed. Right, the definition. The distance covered by a body.
ಆ ಕಡೆ ಏನಾಗಲ್ಲ.
Distance covered by a body in unit time.
ಹೋಗಿತ್ತದ?
Unit time is called
ಹೋಗ್ರಿ ಏನಾಗಲ್ಲ.
speed. The distance covered by a body in unit time is called speed. Written up.
Yes, sir.
Observe this speed. The definition of speed includes two physical quantities. Could you identify?
Distance and time.
Very good. One is distance and another one is time. If there is the word called time, we go for using another word. Could you tell what is that? I'll give you an example for this. Last year, in your previous classes, you have learnt about work done. Is it not?
1 hour.
It is nothing but rate of doing work. Have you learnt or not? Amulya PK.
Sir.
Yes, sir.
Rate of doing work is called, sorry, rate of doing work is called the power.
Power.
In your previous classes.
Yes, sir.
Rate ಅಂತ ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ there work has to be done is to be calculated in the given time. That is why we use the word rate. Distance is covered in the unit time. Hence, can we say that speed is nothing but rate of distance?
Yes, sir.
Okay, yes. Right. Another definition. The rate of distance. Rate of distance traveled by a body is called speed. Or you can also write this as just it can be written as rate of distance is nothing but speed. As you said, speed depends on two physical quantities. One is distance and second one is time. Hence, you can write the speed formula as
Distance by time.
distance traveled or just distance. Distance traveled
By time taken.
time taken. Or just you may write only time. Do remember, speed is denoted by the symbol V. Speed is denoted by V. It is equal to distance traveled is denoted by small d. Time is denoted by small d. This is symbolic representation of speed formula. Next, it's SI unit. Look at it.
Meter per second.
Using this formula only, you can find out
Meter per
the SI
second.
unit of speed. What is the SI unit of distance?
Meter.
What is the SI
Meter.
unit of distance? Meter.
Meter.
Second.
Just to look at the board, don't write. And what is the SI unit of time?
Hour.
Second.
Seconds.
Second.
Second.
It is meter per second. System of international unit of speed is meter per second.
Meter per second.
Meter per second. And symbolically, it is to be written as F or S or S. F, S raised to the power minus. For
Yes, sir.
a simple question. Could you tell what about my state? Am I at rest or am I moving?
At
Rest.
rest.
I am at rest.
Rest.
What is
Rest.
the distance covered by me?
Zero.
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 What is my
Zero.
speed?
Zero.
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 So the speed of a body is zero when it is at rest. Got it? When a body is at rest, its speed will be zero. What about your speed? All of you are sitting in one place.
Zero.
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 No.
At motion. Zero.
Wait. If I start moving, I cover some distance for every unit time. ಒಂದೊಂದು ಸೆಕೆಂಡ್ ನಾನು ಡಿಸ್ಟೆನ್ಸ್ ಕವರ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. When I'll be moving, can you say that I'm moving with some speed?
Yes, sir.
Yes, sir.
You can.
Yes,
So
Yes,
it is
sir.
whether it is more than zero or less than zero. If I'm
More
not
than
moving,
zero.
More than
More
zero.
than
more than zero.
more than zero, whether it is positive or negative,
Positive.
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 speed will be
Positive.
zero or positive. Right. It may be zero or
Positive.
positive. It may be zero or positive. Ora,
Yes, sir.
Yes, sir.
Yes, sir.
the speed of a body can be measured by using a device. And usually in vehicles, there will be a device installed
Odometer.
on the handle side.
Speedometer.
Odometer.
Speedometer.
Speedometer.
Very good.
Speedometer.
Odometer is used for measuring the distance covered. But speedometer will be there. Speedometer is used for finding the speed of moving
The
vehicle.
vehicle.
Here we have in one only both can be shown. Odometer and speedometer. Okay. If you want to find out the distance, you have to go through this dials. Numbers will be there. And here you can see, you can observe there is a circular scale. Can you see that? Circular scale.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Indicates with what
Yes, sir.
speed the vehicle is moving.
Moving.
Okay, this is a speedometer. So the device used to measure the speed of a moving body is speedometer. Right down. Right down. It is speed is measured by using the device speedometer. Over. Quickly write about velocity, quick as possible. Second one, velocity. Right. Velocity. It should be finished within 2 minutes. Here, in case of velocity, we will go for taking
Displacement.
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 Displacement of a body.
Displacement.
The displacement of a body in unit time. Displacement of a body in unit time is called velocity. or the distance covered by a body in unit time in the given direction. Direction mentioned, again it is called velocity. Of a body in unit time called velocity. Now, another definition, right?
The rate of displacement.
Some unwanted sound is coming.
Ketan,
Dear students, you have to observe that.
Ketan, Ketan.
The rate of displacement of a body, the rate of displacement of a body, the rate of displacement of a body is called velocity. The rate of displacement of a body is called velocity. Write its formula. Velocity is equal to
Displacement by time taken.
displacement divided by time taken, or just time. Displacement by time. And write a symbolic formula. V is equal to, how do you represent displacement?
D dash.
D. Yes.
Yes or
T
D
over
dash.
the arrow mark, or yes. S by T. Or V is equal to D over that put arrow mark and write T. Next, SI unit is same. Meter per second. SI unit, meter per second.
Sir, velocity and speed all are small v, sir.
Oh, yes.
Or bigger v. Both are same now, sir.
ಎರಡು ಕೂಡ ಸೇಮ್ ಅಂತ ಅಂದ್ರೆ ಇಲ್ಲಿ ಫಾರ್ಮುಲಾ ತಗೊಳ್ತೀವಲ್ಲ ಡಿಫರೆನ್ಸ್ ಇದೆ. There V equal to D by T, this is V equal to S by T.
Yes, sir.
Now, velocity, it may be 0, positive or negative. ಯಾಕೆಂದ್ರೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಇದೆ. Displacement is, it may be 0, positive or negative. ಹಂಗಾಗಿ velocity may be 0, positive or negative. So this is the information about velocity. And we have very good information regarding speed and velocity. So let's go for learning them in tomorrow's class. Hope that you're all reading the textbook. Are you all?
Yes, sir.
If you have
Yes,
textbook,
sir.
please
Yes,
read.
sir.
If not,
Yes, sir.
today I'll send
Yes, sir.
PDF of
Okay,
this
sir.
chapter.
Okay.
Okay, it's a time up. Let's go for concluding the class.
Thank
Shall
you,
we?
sir.
Yes,
Thank
sir.
you, sir. Thank you, sir.
Thank you, sir.
Yes, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
We have solved some important problems and we have come across the distance differences between the speed and velocity also. Please do practice them today itself without fail. So with this,
Okay, sir.
let's stop the class. Thank you very much.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you.